Good day, students. So for today's video, we're going to discuss converting a normal random variable to a standard normal variable and vice versa. Okay, so for the resource of this lecture, it came from the YouTube channel WowMath. Okay, so let's start. So before we proceed with our discussion, let's have first a review of what we have discussed so far. You must first understand the three main statistical terms that we're going to use. Okay, first is the mean, second is the variance, and the last one is the standard deviation. So when you say mean, it is a statistical term that represents the average of a set of numbers. So you encountered getting an average, correct? Alright. It is calculated by adding up all the numbers in the set and then dividing by the total number of values in the set. So the mean is commonly used to describe central tendency in a data set and is often referred to as arithmetic mean. So what is a variance? And why do we have to solve for the variance? So because in statistics, variance is a measure of how spread out a set of data is. It is the average of the squared differences from the mean of the data. So variance can be used to determine how much variability or dispersion there is in a data set. Okay. So a small variance indicates that the data points are clustered closely around the mean, while a large variance indicates that the data points are spread out over a wider range of values. Okay, so how do we solve for variance? Variance is actually the average of the squared difference from the mean of the data. So mathematically, variance is defined as the expectation of the squared deviation of a random variable from its mean. Why do we have to get the standard deviation? A standard deviation is the square root of the variance. So why? Why do we have to do standard deviation? So standard deviation is a statistical measure that tells you how much the values in the dataset vary from the average or mean value. So almost it's the same as variance, right? If we have the variance, why do we have to compute for the standard deviation if we have the variance? Okay, so what is the reason? So in general, standard deviation and variance are both measures of the spread or variability of a set data. The variance measures the average squared deviation of each value in the data set from the mean, while the standard deviation is the square root of the variance. So basically, it's about the units of measurement. The variance is expressed in squared units of the original data, which can make it difficult to interpret. In contrast, the standard deviation has the same units as the original data, which can make it easier to understand the spread of the data. Variance is expressed in squared, so while standard deviation is expressed in linear form. Okay, that is the reason why do we have to get the standard deviation if we have the variance. And of course, we cannot get the standard deviation if we don't have the variance, and we cannot get the variance if we don't have the mean. Okay, so did you understand? So those three terms, those three statistical terms are very important. They are the foundation, they are the basics of z-score, okay, or the z-value. That is our topic for today, the z-value. Based on this illustration, the normal distribution curve or the bell curve is divided symmetrically into negative z-score and positive z-score. The midpoint is the mean, okay, which is in standard form, it is 0. My question is, why z-score important? Our previous topic, we already used the z-score by using the z-value table. There is a given z-score, you get the area that corresponds to the z-score or the z-value. So the question is, why z-score important? In statistics, the z-value, also known as the z-score, is a measure of how many standard deviation a data point is away from the mean of a distribution. So basically, the z-score tells us how many standard deviation the data point is away from the mean. It's either above the mean or it is below the mean. So of course, if it is above the mean, it is in the positive side of the z-score, and it is below the mean, it is in the negative z-score or z-value. So how do we compute for z-score or the z-value? Not all the time we will get a z-value that is equal to 0, is equal to 1, equal to 2, equal to 3. It is almost always we will never have a 0 mean. So that is the standard based on the normal distribution curve. Your mean is 0, okay, and your standard deviation is 1. So how do we standardize if the mean is not 0? So what do you mean by standardize? So when you say standardize, we will convert it to standard. So we will standardize it using the z-score formula. We can interpret any mean and standard deviation given that it is normally distributed. We can standardize it using the z-score formula. So what is the z-score formula? So the z-score formula is x minus mu over standard deviation. So what is x? So x is in any data value in normal distribution. So it is the raw score from the data, and you want to standardize it. What is the z-value of that specific data in relation to the mean and the standard deviation? So where z is standard normal score or z-score, x is any data value in normal distribution, mu is mean, and sigma is standard deviation. Okay, so let's have some examples so that we can understand further and that what is the purpose of this formula. If the z-score is positive, so the positive score is above the mean. If the z-score is 0, the score is the same as the mean. If the z-score is negative, the score is below the mean. So those are some basic concepts about z-score. Example number 1. Determine the z-value for each of the following x values for normal distribution, with mu or the mean is equal to 16 and standard deviation sigma is 3. Okay, so here is the formula. Z is equal to x minus mu over sigma. Letter A, B, C, D. So here are the raw data or the x values. So letter A, x is equal to 12. Without using your calculator, just by inspection, can you solve? So let's try. So using the formula, 12 minus 16. What is 12 minus 16? And by the way, if you can see, if the data or the x value is below the mean, so therefore the z value is a negative value. Why? Because the raw score is below the mean, so therefore it's negative 1.333 or 1.33 approximately. Okay, so letter B, again, x is equal to 8, it is below the mean. Okay, so comparison to letter A, it is further below the mean. 8 minus 16 is 8, negative 8. Okay, divided by 3, so it is negative 2.6666, or rounding off to 2 decimal places, it is negative 2.67. Okay, so it's very easy, right? So what is negative 2.67 means? It means if we will convert these x values to standard normal distribution, we will standardize it so that we can get the corresponding area. Okay, so we cannot interpret an x value, a mean, 0, and standard deviation of 1. So we cannot convert it, or we cannot get the corresponding area using the z value if we will not convert it, if we will not standardize it using the z value formula. So let's proceed to letter C. So letter C, x is equal to 22. Obviously, this is above the mean. So the z value is positive, right? So 22 minus 16 is 6 divided by 3. So it is exactly 2. Let's proceed. Letter D, 25. X is equal to 25 minus 16. Okay, 9 divided by 3. So 3 standard deviation away from the mean. Do you understand? So let's proceed to our next example. It's almost the same with the previous example, but in this example, it is in situational form. Given the mu, or given the mean mu is equal to 50 and the standard deviation sigma is equal to 4 of a population of reading scores, find the z value that corresponds to a score x is equal to 58. Find the z value. So just the z value. So again, the formula is z is equal to x minus mu over sigma, or the raw score, or the x value minus the mean over standard deviation. Now, when your teacher asks you to illustrate the given. So first, you will draw the standard normal curve, or the bell curve. So when you say standard, the midline is 0, or the mean is 0, and each standard deviation is 1. The given situation is written below. So 50, 54, 58, 52, 62, because the standard deviation is 4. So find the z value that corresponds to 58. Thus, so in conclusion, the z value that corresponds to the raw score 58 is 2 in a population distribution. So therefore, the score of 58 is above average. Okay, clear? Okay, so another example. Locate the z value that corresponds to p scores of 39, given that mu, or the mean, is 45 and standard deviation is 6. If you will inspect, 39 is below 45, so we will expect a negative z value, correct? So 39 minus 45, negative 6 divided by 6, so it's negative 1. So the z value is negative 1. So if you're going to illustrate again, so the mean is 45 and the standard deviation is 6, so minus 6 on the left side and plus 6 on the right side. Okay, so when you say z value is negative 1, so it is below the mean. So 39 is exactly 1 standard deviation below the mean. Thus, the z value that corresponds to the raw score 39 is negative 1 in a population distribution. The score of 39 is below average, so exactly 1 standard deviation below the mean. Next. Okay, so let me read the problem. A consumer group tested a sample of 100 light bulbs. It found that the mean life expectancy of the bulbs was 842 hours, with a standard deviation of 90 hours. Okay? One particular light bulb from the DuraBright Company had a z-score of 1.2. What was the lifespan of this light bulb? Pause the video and try to answer. How do we solve this? So let's write the given. Of course, the formula is z is equal to x minus mu, or the raw score minus the mean over standard deviation. And if you will write the given, so z-score is already given. It is positive 1.2. Okay? Mu is, or the mean is 842 and standard deviation is 90. So what are we solving? So we are solving for that specific light bulb. So how many hours did that specific light bulb, what is the lifespan of that specific light bulb? So we are solving for x. So x is not given, so therefore x is unknown. 1.2 is equal to x minus 842 divided by 90. So what is the first step if you have that kind of an equation? So there are different ways in solving mathematical equation. So this is my method. So first, I will eliminate the denominator, which is 90, so that we can isolate the x. Okay, so how do we eliminate 90? So we can multiply both sides by 90, right? So that 90 can be cancelled. On the left side, 1.2 times 90. So what is 1.2 times 90? 108. Okay, so we will have 108. Then on the right side, 90 will be eliminated. The denominator will be cancelled. And we will left with x minus mu, or x minus mean. So what is the second step? So the mean must be transposed to the left side. It will be combined with 108. Correct? Because it is in negative 844. So if we will transpose it to the left side, it will become positive 842. Okay, so another way of saying it, we can use the addition property of equality. Okay, so we will add 842 both sides of the equation. So we will add 842 to 108, and we can add 842 on the right side, so it will become 0. Did you understand? So basically, 108 plus 842 is 950. What is 950? Okay, so what is 950? 950 means that is our answer. What is the lifespan of this light bulb? So the lifespan of this light bulb is 950 hours. So that is a real life situation application of the concept of z-score. We can solve for a particular value of x given the z-score, the mean, and the standard deviation. Let's have another example. For a continuous random variable that has a normal distribution with mean of 20 and a standard deviation of 4, find the area under the normal curve from x is equal to 20 and x is equal to 27. So what do you mean by this? The question is about the area under the normal curve. When you say the area under the normal curve, we will use the z-value table. So I provided already the z-value table. So I hope you have the copy of the z-value table. So how do we find? Basically, this is between 20 and 27. Find the area under the normal curve from 20 to 27. I suggest you illustrate so that you can have a conceptual understanding or visual representation of what is happening. Later, we will show the picture or show the illustration. So how do we solve this? So in solving area under the normal curve between two x values, the procedure or the method in finding the area or the probability is, of course, one of the purpose of the z-score is to give you the area under the normal curve. Okay, so that is the purpose of the z-score. So the purpose of the z-score, aside from giving you how many standard deviation a data point is away from the mean of distribution, aside from that, the z-score will give you the area under the normal curve. So if the z-score can give you the area under the normal curve, and you're asked to find the area under the normal curve from two x values, so therefore you will get the z-value of each x value. Okay, so let's start with 20. So 20, what is the z-value of 20? So 20 minus 20 divided by 4. So 20 minus 20 is 0. 0 divided by 4 is 0. So 20 is exactly, the location of 20 is exactly in the mean. So 0, because it is the same with the mean. How about 27? So 27 is above the mean. It is in the positive. So 27 is 1.75. So how do we get the area under the normal curve? Okay, so we will look at the z-value table. So 0, the area of 0 is 0, while 1.75 is 4599, 0.4599. So what does it mean? So because you were asked to find the area under the normal curve from 0 to 175, so 0 to 0.4599. So you will subtract, okay, 0.4599 minus 0. Okay, so that you can get the area under the normal curve. Okay, so therefore, the area under the normal curve between x equal to 20 and x equal to 27 is 0.4599. Okay, so this is the illustration. So based on the illustration, it is 46, approximately 46%. The area under the normal curve between x is equal to 20 and x equal to 27 is approximately 46% or 0.46. Okay, did you understand? Okay, so for this example, the scores of a group of students in a standardized test are normally distributed with a mean of 60 and standard deviation of 8. Answer the following. How many percent of the students got below 72? So, in dealing with this type of questions, below, above, in between, we will use notations. And so first, we will solve for the z-value. So let me show all of the questions. So B, what part of the group scored between 58 and 76? Letter C, if there were 250 students who took the test, about how many students scored higher than 64? So let's solve for letter A. How many percent of the students got below 72? So let's illustrate. So let's try to illustrate this. Okay, again. So how many percent of the students got below 72? So here's the illustration. So 72 is approximately, based on the illustration, it is between 68 and 76. And we know 68 is one standard deviation away from the mean and 76 is two standard deviation away from the mean. So based only on the illustration, we can assume, we can conclude that it is, the z-value is 1.5, correct? So let's see if our answer or our estimation is correct. So using the formula, z is equal to x minus mean over standard deviation. X is 72 and mean is 60 divided by 8. So the answer is 1.5. Okay, so based on the picture, or based on our illustration, our answer is correct, 1.5. So what does 1.5 means? So the corresponding z area, z is equal to 1.5, is 0.4332 using the z-value table. Okay, so kindly check. Then the notation, I wrote the notation P means probability, okay, or the area under the normal curve. Okay, so the area that correspond to 1.5 is 0.4332. So what do we do with 0.4332? So if we will check our illustration, 0.4332, if we will shade 4332, it is below 50% or 0.5. But our illustration shows that it is more than 0.5. So do you think 0.4332 is considered as the answer to our question? How many percent of the students got below 72? By the way, when you say below, it is on the left side of the raw score of the x value. Find 72 on the standard normal curve, then shade the left side because it tells us below. 0.4332 is not correct based on the illustration, based on the part that is shaded. So what do we do? Okay, so we must add 0.5. Is this the correct notation? Yes, because you are asked to get the area of the z-value below 1.5. Based on the illustration, is 0.5 plus 0.4332. So the total is 0.9332. But the question asks us in percentage, so times 100. So the final answer is, so in conclusion, how many percent? The conclusion is the percent of the students that got below 72 is 93%. Do you understand? Okay, so let's proceed. Letter B. The same question, or the same situation, but different question. Letter B, what part of the group scored between 58 and 76? So we already have an example earlier about getting the area under the normal curve, or the area of the z-score that is between. Okay, so first, of course, we will solve for the z-score of 58 and the z-score of 76. If you will notice, 58 is below the mean and 76 is above the mean. Okay, so when you encounter a negative z value, right? So this is the corresponding z value of 58 is 0.25, while 76 is above the mean, which is a positive value 2. So the corresponding the corresponding area of negative 0.25 and 2 are, first, let's illustrate so that we can have an idea of negative 0.25 to 2. So what do we do with the corresponding area of the z value? 0.09987 and 0.4772. Shall we subtract? Shall we add? Okay, so in dealing with negative z value and a positive z value, the area that is between those z value, if you will analyze, the area came from the left side of 0, then to the positive side of 0. So it covered a wide range of area. Do we add or do we subtract these two areas? So logically, we will add because it covered a wider area. So from negative side of 0, from the left side of 0, which is a negative, and to the positive side of 0. Therefore, so we will add, then get the percentage. So therefore, about 57.59% of the group got a score between 58 and 76. Okay, so that is our conclusion. Letter C. If there were 250 students who took the test, about how many students got higher than 64? So the earlier problems ask us about probability, or the area, the probability. This question asks us the specific number of students after getting the probability. About how many, so approximately about how many students got higher than 64. Before we can answer this question, we must get first the probability, correct? Okay, so let's first solve for the probability. This is above the mean. 64 is above the mean, so 64 minus 60 divided by 8 is 0.5. So what do we do with 0.5? So let's the area under the normal curve of 0.5. The illustration for 0.5, above. So how many students got higher? So above, higher. So this is the illustration. So 0.5, then you will shade the right side. So because we are asked to get the students scored higher than 64. 0.5 is 1915. What do we do with 1915? Illustration. Do you think this is 19%? Okay, so 19% is incorrect because 19% is from 0 to 0.5. That is 1915. So what do we do with 1915? We will subtract to 0.5 so that we can get the actual area. Okay, so the actual area is, what is 0.5 minus 0.1915? 0.3085. So what do we do with 0.3085? There were 250 students. So that the probability of students scored higher than 64 is 30% or 31%. So that probability, we will multiply it to 250. So we will get 77.13. So approximately 77 students got a score higher than 64 if there were 250 students who took the test. If you have a question, clarification, you can answer the You can put it in our Google Forms evaluation for today's discussion. Okay, so that's all for today. Have a nice day. Bye bye.